For all those restorers out there who've been following my videos, I've got to tell you that I've found another addiction, and that is cleaning. As you may recall, I said the next step was checking power supply and then the power amp and following the usual routine. But this time it just went haywire with the cleaning. I decided to clean up the front panel so that I didn't have to work on a grubby radio, and found myself really doing the whole thing, as some of these before and after pictures will show. This whole thing was cleaned up, those gold trims were redone, all the knobs came out beautifully, and basically we've got ourselves a completely clean front panel, which included the painting of that back section. That cream back section that you see there, that was all chipping away, and that got repainted, and now it's bright again, and the knobs all shiny, or as shiny as they'll get. This thing is 63 years old, no wrinkles, which is great. So even some of the top got cleaned, not completely as you can see there, but it does clean up very, very well, which is great. As you can see, not the entire surface has not been looked at, because that side is still in its original state. But anyway, this will be cleaned as I go along. I try to get sections completed, and what I found with these is that when you feel like doing something, just do it, because you might not feel like doing it later. And cleaning is something I really hate to do, but this one really got to me. All right, so back on track now. We're going to be looking at the power supply to see if we've got a working radio, because if this is not working, then the last laugh is certainly not mine. If I do all this work and find that I've got a blown output transformer or power transformer, I definitely will not be laughing. So the next step now is check the power supply, the filter capacitors, that can over there, and get this thing back on track. Let's have a look at the power supply section of the schematic. It's standard up front. You've got the mains coming in here. You have a switch. We have on the other part of the mains, you have a 0.7 amp fuse. It then comes in and meets these two capacitors. This capacitor 153 is a 5 nanofarad across the mains line. This one is from mains to ground. These are noise suppression capacitors. These are the guys that need to be removed and replaced with safety caps, because if they short, they'll actually short out the mains, or they will connect one of the mains lines directly to the chassis. So these guys have got to go. This guy goes into the primary. That guy goes into the voltage selector at the back, 240, 220, 127. I'm putting it on 240. It goes into the power supply's primary, but there's actually a line coming out of the primary with a 0.35 amp fuse. Now this would be for lower voltage mains, but I really don't understand why that fuse is there. It's a bit different to what I'm used to. I've never seen one with a fuse in line with parts of the primary, because as far as I'm concerned, these three parts are all in series and part of the primary. So we then have the transformer secondary at this end. The normal part, the low voltage secondary, is down here, 6.3 volt AC for heaters and for the dial lamps. We then have the high voltage secondary, which again has a quirk over here. One part goes to the Selenium rectifier. The other part comes to the Selenium rectifier via a two-way selector switch. Now what this seems to indicate is you can actually select to drop the voltage or up the voltage with the selector switch, and that goes to the other side of Selenium rectifier. Selenium rectifier rectifies that voltage, and you get your B plus over here on this first part of the filter can, a 50 microfarad, and it should be around 270 volts providing 68 milliamps. Now this switch here was a question mark for me. I've never seen this kind of function in one of these radios before, and I've discovered where it is on the radio. And it's a bit odd because it's actually a switch which I mistook for a tone selector. Let me show you. So that switch that we see there, that's actually dropping the output of the secondary transformer, is this guy over here, which I assumed was a tone control because it's by the volume control, and it activates that window over there. And I really don't know what it's supposed to be because it says Sparschaltung, whatever that means. I assumed that was a tone function, but obviously it's not. And I know it's a switch because when I took the whole front panel out, it's on the back there. It's a toggle switch which is activated and deactivated. A two-way selector, exactly as it shows in the schematic. So this thing obviously has the effect of dropping the voltage coming out of the secondary. And we'll check that function when we test the secondary voltage. But it's a new one as well. Again, never seen this before. So that's basically the result of, or the schematic for this first section. Following the build of that schematic part, of the power supply part, is actually quite simple. The voltage comes in there. Part of it, one line of the mains goes to the switch, which is activated with one of these and switched off when I push off. The line then comes back through there. It has the fuses at the back. The two caps that were filtering the line voltage were at the bottom there, and I've taken them out. And then it goes into the primary. The secondary comes out and goes one line to the Selenium rectifier, direct. The other one comes to this switch at the front that I've just shown you, and it goes back through to the Selenium rectifier. So we're selecting the voltage that's going into the Selenium rectifier with that switch. Then from the Selenium rectifier, one part of the Selenium rectifier is grounded, and the other one, the positive, comes to the first section of this filter can. Now, this filter can has three sections in it. There are two 50 microfarads and a 4 microfarad. All of them are high voltage. And what I have done is desoldered the connections to the filter can, and I've reformed them with it's a previous project which I recorded on a video as well. It's a capacitance leakage tester / reformer. And I've reformed all the three sections, which I had to desolder from their connection points over there. And I've reformed all sections to a point where the leakage current is very, very small. This first section, for example, started off with about 2 milliamps, and after a night reforming, it came out at 200 microamps, which is pretty good. Let me just put that on and see if we can get an example. It's at high voltage, so it should do that. Now, that's the 1 milliamps range, and it very quickly drops to, that's 300 milliamps, coming down to 200 and something milliamps, 200 milliamps, which is 200 microamps, sorry, 200 microamps, 0.2 milliamps. And it settles between 100 and 200 microamps, which is a hell of a lot lower than the 2 milliamps that I found it at. Now, I did this for all the sections. The difference with this filter can is that it doesn't have connectors at the bottom. It actually has wires coming out, and those wires go straight to the points where they are connected in circuits. So I had to desolder those wires from the circuit, do the reforming, and now I have to solder it back. So I'm happy that the filter can is doing its job. I really hope the rectifier and the transformer do theirs. We'll test that next. Right, enough faffing about. I've connected the speaker connection to the points that I marked off earlier. That goes then to that little plug and socket, which then goes to my speaker over there. As I said, that's something I use because it makes it easier to move this around. I don't have speaker wires hanging around anywhere. It's nice and clean. The next thing I've done is I want to test the output transformer. So if we look at the schematic, if I want to test the speaker and the output transformer rather, what I'm going to do is I'm going to input a signal from the signal generator into the primary of the power transformer. So I'm putting it reference to 0 to ground. Actually, I shouldn't do that, should I? One point's going to go to pin 7 of the tube of the EL84. That's one connection to the output transformer. And the other one, the other output transformer point would be this wire here that goes to the Selenium rectifier. So I'm going to connect the signal generator there, and we should hear a signal on the secondary, so we should hear the signal coming through here. So let's just do that. So I've got a signal coming from the signal generator. I've got a 500 Hertz tone. And it's going to pin 7 of the tube socket, which is one connection of the primary of the output transformer. The other one's going to the filter cap output there, which is the other connection to the output transformer. And if I switch on the signal generator, I've got sound. Put that up a bit. We're actually getting the beep coming out of the speaker, so the output transformer is fine, which is great. Right. So the next thing I want to know is if the power transformer and the power circuit is fine. I've checked the diodes, I've looked at the wires coming in, everything seems to be okay, but I'm going to switch it on now. I've taken all the tubes out. So what we should be getting is very little current. There are no heater voltages. The lamp should go on. And I've connected my multimeter to the first section of that filter cap so that we can measure the voltage across there when I switch it on. Then I have prepared the dimmer with only one light active. So this is as much restriction as you can get from this. And I'm going to switch it on. Now the radio is still off. So here comes the moment of truth. I'm going to hit the FM button and see what happens. Here goes. Oh, dude. Okay. Right, the lights have come on. And I've got 324 volts on there, which sounds about right because there's very little current being drawn. On the dimmer, I can read 60 milliamps coming through, practically full voltage, so it's not reducing much. There's not much current going through here. So at least that's working. Now what I want to test is this funny button over here, this funny switch that I mentioned, which says saving power mode or something like that. So let's look at the voltage when I activate that switch. Right, here goes. That's dropped it. Actually, it's still dropping it. That will be the voltage on the filter cap coming down. Let's see where it comes to. 170, 160, Well, that's about half. So that power saving switch there brings the voltage down to about half. Let's put it up again. 320, 160. Yeah, it actually halves the voltage. Okay. So I know what that does now. It actually brings the whole power range, power consumption of the radio down to half its nominal voltage, which is a bit weird, because that means all the B pluses will come down to half, and I'm not even sure that that should work. Well, we find out soon enough. Right, so the next thing I'm going to do, I'm going to clean up the valves, and I'm going to put them in, and the next time we test this, it will be testing for sound. See if we've got something that's alive, or if I've just wasted a hell of a lot of time on a cleaning job. Okay, I think I'm ready for the power up test. The tubes are back in. I've checked that I've got the right ones in the right sockets. It wouldn't be fun if I got that wrong. So this is what we're going to do. Speaker is connected. I have the multimeter connected to the first section of the filter cap, so I'm going to be measuring B plus under load. I got the dimmer off at the moment, it's active. All these are off except the 40 watt bulb, so it's on maximum protection. I'm going to put it on here on medium wave, and so that I'll control the switching with the dimmer switch there. And now I think we'll watch the dimmer as I power up. So, I think I haven't forgotten anything. If I have, we could hear a bang, so let's give it a try. Here we go. Right, the light dimmed, went bright, then dimmed. It's rising again. The dial lamps are on. I'm reading 280 volts and climbing on the B plus. It's a bit high. I'm supposed to get maximum of 270. Oh, it's dropping now. So the light dimmer should be going brighter. Yep. Okay. I don't hear anything. Got the volume on maximum. And I'm starting to hear some crackle. Volume's on max. I hear a crackle, and I've got no shorts, no smoke. That's good. All right, I'm going to put on another one of these lamps, so reduce the resistance there, and it's coming up. Brilliant. 140 milliamps, 150 milliamps drawn there. I can hear the hiss. I've got 251 volts of B plus, 220 volts over there. I think I'm going to leave it at that. I'm not going to risk putting on the other two lamps yet, because there may still be something wrong. So let's have a look at what we're getting here. I've got 240 volts on there. Speaker's crackling away. I put my long wire antenna in the back. Let's see where we are in medium wave. Hey, we got something. Well, sort of. Don't expect much on medium wave as usual, but it's making the right noises. Okay. That volume's got to come down. I had the ferrite antenna on, so I'm going to take it off, see if it improves reception at all. Yep. We've got our one station coming through. Brilliant. Put the ferrite antenna on, and it's not doing too well. Oh, there it is. I can rotate the antenna. Nothing there. Rotate it in. Okay. Right, so far so good. Let's try a long wave just for noise. Yep. I don't get anything there anyway. Short wave. Get rid of the ferrite antenna. Hey! It's picking up. Okay. Ah. It's actually pretty sensitive. That's great. Right, let's try FM. This is the big test. Better put a little wire antenna at least at the back. Just a little short wire antenna. Haha, we got it with FM. Brilliant. It's not bad. Hey, not bad at all. It's a bit distorted. All right. Treble works. Bass is not that responsive. Okay. Let's get a voice station here. What I want to try is this thing. So that's on maximum voltage. Oh, I see. It goes down a lot, especially on FM. Alright, so this I presume is if you have very strong stations, you can drop the power. It drops the B+, and just how much does it drop? Well, with the limiter on, we've got 230 volts there, 32 and 120, so almost half. So it does drop the voltage quite significantly. Okay, brilliant. So this guy's actually got life into it. It's not just clean. I still haven't seen any smoke. I will be testing this to check for temperature rise on the power transformer and the Selenium rectifier and the filter caps. But so far, very promising, which is a great bit of news, because after the last one I did, I was really frustrated with everything basically not working. This one is going to be an improvement job rather than a repair. So I'm going to do the usual thing, going through capacitors, resistors, checking components in general, replacing the caps, and then I'll be testing the quality of the audio amp, and then going backwards and trying to improve reception. All right, good. Phew. That is a relief. Onwards. Bye for now.